Hello and welcome to an example of an AI agent, in this case Claude, design the cold-form steel framing for a simple house, using the North American standard for cold-form steel framing. Prescriptive method for 1 and 2 family dwellings, AISI S23019. On the right side is the video of Claude completing the design process without any human intervention. The video is at 4 times real speed. The full design was completed by Claude in a single shot taking 17 minutes. On the left side, we will look at the details of how Claude independently completes this design. Okay, so here's the house plan I gave Claude. It's a relatively basic 3-bedroom home with overall dimensions of 9 meters by 11 meters and is slab on ground. The plan actually had another level, however I told Claude it is single level for demonstration purposes. So I've used a pretty standard prompt here, telling Claude to use my RAG for the AISI S230 standard for cold-form steel framing to obtain the sections, equations, and tables for the design. I asked for 2 reports since sometimes Claude gets a bit clunky with long reports. I request trusses for the roof for economical reasons. So first Claude asks for some missing information: design wind speed, snow load, seismic category, and ceiling height, for which I gave values of high wind and low seismic and snow values. Then Claude queries my connected RAG database for the necessary design information. Claude does these queries independently, and we can see the 13 queries made here, relative to applicability limits, wall stud size selection tables, headers, wall stud minimum size tables, braced wall panels, roof trusses, stud thickness tables, truss to wall uplift strap, roof sheathing fastening, box beam header tables, Jack King stud tables, stud thickness, Jack King studs minimum number. Okay, so we can see that Claude is able to flick around the specification to multiple different chapters in order to collect all the bits and pieces required for the design of the roof and wall framing, in much the same way that a human would. So Claude now has all the rules, tables, and equations for the design. We will look at the reports to follow the exact methodology used by Claude to design the steel framing. So while I told Claude simply to detail the light gauge cold-form steel structural framing, Claude has correctly interpreted from the S230 standard the steps required, as indicated in the report, quoting, "Wall framing comprises cold-formed steel, CFS, C-section studs, U-section tracks, headers above openings, Jack King studs, corner framing, braced wall lines, and the connections that transfer gravity and plane shear and uplift loads from the roof and ceiling assemblies down to the foundation. Roof framing, trusses, ceiling diaphragm, uplift connectors at the bearing wall lines is covered in Part 2 of this report." Okay, so for the wall framing design, we step through the project geometry and interior layout. Then the design basis, which includes the standards, material properties, site loads, load combinations, and the special treatment of the high ceiling height in a high wind zone, as noted in the following applicability to AISI S230 check. The wall construction details the connection to the foundation and the uplift demands of the high wind zone. The wall studs are then selected from the appropriate tables in S230, including exterior load-bearing walls and non-load-bearing walls, and interior non-load-bearing walls. Stud bracing and corner framing requirements are specified. The chapter on headers includes a detailed header schedule, details of connections to king studs and uplift strapping. The Jack and King studs and box headers are then designed. A detailed chapter on wall sheathing and bracing details the predominantly wind-based design of the lateral bracing system and hold-down anchors. Finally, some checks, additional detailing, and a bill of materials is provided. Okay, so in the roof framing report, after the same initial introductory chapters as in the first report, the roof trusses are described. The roof trusses will be purchased from a retail manufacturer, and the report details all the required design data for the supplier. Again, due to the high wind zone, attention to strapping for uplift forces is required. Similarly, lateral load design in the roof is required, and is satisfied with sheathing both on the truss bottom chord ceiling and the truss top chord roof sheathing, including appropriate fastening for diaphragm action. The design completes with the ridge connection, overhang, and outlooker details, roof and ceiling diaphragm checks, openings and web holes, connection summary, and bill of materials. The drawings provide wall plans with framing details, wall elevations with strapping detailing, gable end wall design, detailing for openings, corners and anchoring, and sheathing and fastening details for the shear walls and ceiling and roof diaphragms. And finally, the roof drawings provide the roof framing plan, indicative truss elevations, strapping details, ceiling and roof diaphragm details, and the roof sheathing layout. Set up your free structural steel design RAG to use with any AI LLM model. Step 1. Download the free RAG vector databases from steelcoldform.com. Step 2. Follow the instructions on the engineering RAG page to set up the API for running queries. Step 3. Connect your LLM of choice to your RAG API, allowing your AI agent to query your RAG as required. RAGDBs were created from free PDFs of the specification provided by AISI, and AISI. All RAGDBs are provided free to promote the use of Steel.